Hello everybody. I will be starting a particular course called Basic Electrical and Network Theory. First, the reason behind starting that course is purely looking at the upcoming examination of GATE 2022. In this particular course, I will be going through all the theories of basic electrical and network, and after that, each and every topic corresponding to each and every topic, we will be solving the previous year GATE questions. Okay, so let us start from the very basic, and we will be starting from the very basic, and obviously we will go to the higher or tougher topics, and we will continue to solve the previous year GATE problems. Okay. So let us begin with the first important thing. Whenever you are talking about electrical, okay, the most important thing is what is most important thing? The important thing is charge. Okay, most important thing is charge. We will be dealing with charge. We will be dealing with charge. We will be dealing with charge. And what is the symbol of this charge? The symbol of charge is Q. But the problem here is that whenever you are dealing with charge, and if the circuit is very complex, if it is a complex circuit, okay, it is very difficult to deal with charges. So we need some simple parameters, or the system parameters you can say, so that we can solve the complex problems of the system in a simpler way. So what are those parameters we'll be dealing with in electrical engineering or all electrical circuits, so that we can get all the characteristics of the systems, we can get all the information, and we can also solve all the circuit related problems in a better way. So that parameters are current, which is I, and voltage, V. Okay, so we will be mostly talking about current and voltage. Now here question comes, how this charge is related to current and how this charge is related to voltage. So the next topic on which I will be discussing the relation between this charge and all the units of charge and current and voltage. Okay. So let us start with charges. Sorry, let us start with current. So what is current? So what is current? What is current? That is very important. What is current? Current is nothing but, if we denote current in I, then the current is dq by dt. That is change in, or you can say the rate of flow of charge, charge is called current I. Okay, the rate of flow of charge is called current. So let's say you are having a conductive material, starts from A and it is ending at B, and a positive charge is flowing through this particular conductive material. Let's say this charge is 1 coulomb, and the rate at which this 1 coulomb of charge is flowing through this conductive material is in 1 second. So in this, through this conductive material, in 1 second 1 coulomb of charge is flowing. So then the current in this particular conductive material will be 1 coulomb divided by 1 second, which is 1 ampere. Okay, so the current is nothing but rate of flow of charge in a conductive material, and the unit of the current is ampere. Unit of the current is ampere. Okay, now another point I like to highlight here, the flow of charge which shows the 1 ampere current, that charge is the positive charge. The charge is positive charge. Whenever there is a positive charge flowing in a certain direction, and in 1 second you are saying 1 coulomb of charge is flowing, then this current value will be 1 ampere. This current value will be 1 ampere. Okay. Now the next part on which we will be discussing is the voltage. What is the concept of voltage? Concept of voltage. We will be discussing the concept of voltage right now. What is voltage? First, we need to draw some analogy between the gravitational force and the electrical force. Okay. So let's say there is one. This is the Earth surface. Let's say this is Earth surface. Okay. Now, obviously, the gravitational force will be in this particular direction. Now, a particular body is situated here in position 1, and you pull it in the position 2. Now the energy which will be stored in for in this particular material while transferring this material from position 1 to position 2 will be mg h2 minus h1. So this is the static energy will be stored in this particular material while transferring this material from this position to this position. Now, if we draw the similar analogy in case of electric field, let's say this is one electric field, and in this electric field you are putting one positive charge of 1 coulomb. Now this charge accelerates in this particular electric field from this position 1 to position 2. Okay. So the energy which will be stored or gained by this 1 coulomb of charge is nothing but the value of charge into the potential difference between point 1 and point 2. Okay. So what we can say, the potential difference actually helping the charge to flow from one point to another point. So with respect to this potential difference, we can have a important concept. Say this is point 1 and this is point 2 of a conducting material. Okay. Now 1 coulomb of positive charge is flowing through this conductive material which is having the potential difference of 1 volt. So the energy which will be stored or which will be gained is 1 coulomb into 1 volt, which is 1 joules. Okay. Now similarly, whenever the rate of flow of charge is 1 ampere, that is 1 coulomb of charge flowing in 1 second, which is nothing but 1 ampere and which is flowing in between 1 volt of potential difference, then the power gained by the charge will be 1 joule divided by 1 second, that is 1 watt. Okay, clear?